We are still continuing with, our questions on circuit theory, and then let's look at some objective questions in the core mathematics Ghana edition. Question 16. This was one of the objective questions. Question 16. Okay, so in the diagram, O is the center. O here is the center. Find angle QPR. A 42, B 48, C 54, and B 56. Angle QPR. QPR. So this particular angle here. All right. So how do we find the angle here? What we know is that there is a relationship between this particular angle at P and then the angle at ROQ here. Okay, the angle here and the angle here. There is a relationship. State that the angle that subtends at the center of a circle from an arc or a chord is twice the one that subtends at the circumference of the circle from the same arc or chord. All right, so what we can say that whatever angle is here, okay, when you divide by 2, you get there, because this is twice of this. So whatever angle you get, when you divide by 2, you get what at the angle here. So since we are given here at 42, what we can do is to find the angle ROQ. Then when we get angle ROQ, we divide by 2 to get angle RPQ. That is what we are looking for, or QPR. That's what we are looking for. So since we know here as 40, how do we get the angle here? Okay, so let's see. Triangle ROQ. Okay, this is the center of a circle. So OQ and OR are the same because it's a radius from center to the circumference, from center to the circumference. So it makes triangle ROQ to become what? To become isosceles. If that is the case, then we have the base angles to be the same. So we can say that angle QRO is also equal to 42 degrees. So the angle here will also be what? 42 degrees. Since this side is the same as this side, okay? This is a radius, this is a radius. So here is going to be 42. And how do I get the angle ROQ? So my angle ROQ is going to be what? 180. So the sum of the interior angles of a triangle is what? It's 180. So this angle plus this will give me 180. So my angle ROQ is 180 minus the addition of the two angles, this and this. So when I add this and subtract from 180, I'll get my angle ROQ. And my angle ROQ is going to be 42 plus 42 will give me what? 84. And 180 minus 84, I'm going to get 96. Okay, so the angle here is going to be 96 degrees. So that 96 plus 42 plus 42, I get 180, so 96. But I want to calculate the angle QPR. So my angle QPR is half of this particular 96. Here, half of angle ROQ. So half of 96 will give us 48. Is going to give us 48 degrees. So our answer is B, 48 degrees. 48 degrees. So 48 degrees. So our answer is B, 48 degrees. Okay, I believe this is so simple. So you see that this is twice of this. When you multiply this one, we also get here. So let's look at the next question. Question 39, question 38, and question 39. There was also a question on circular theory. Okay. Question 30. We were supposed to use it to solve 38 and 39. In the diagram, PQ is tangent to the circle at Q. Okay, so a tangent is a line that touches a circle at a point. So this point. Angle QOS is 108. O is the center of the circle. Find question 38 OSQ. OSQ. This angle. Okay, so since O is the center, then this side is same radius. So this is isosceles. So it means that this angle OSQ is the same as angle OQS. O angle OQS, let's say X. Okay, so since they are the same, let the two angles be X, so that if here is X, here is also X. Okay, then X plus 108 is equal to 180. So it implies that my X plus 108 will give me 180 degrees, and 2x is going to be 180 minus 108, and 180 minus 108, you are 72 divided by 2 over 2, it will give us 36. So our x is 36 degrees. That is the answer C. 36 degrees. 36 degrees. So our x, and x is angle the same as, which is therefore angle OSQ is 36 degrees. So it means that if here is 36, here is going to be also what? 36. Alright, because this side is the same, so the base angle also become the same. Okay, let's look at question 39. Find angles SQR. SQR, that is the angle here. Question 39. Angle SQR. Okay, angle SQR, that is the angle here. So one of the properties, okay, that we also know, the angle between a tangent, you see QS is a chord, and then PR is a tangent. Okay, it is tangent to the circle at Q. So the angle between a chord and a tangent, okay, is the angle SQR. It's the same as the angle this chord will subtend at the circumference of the circle. So it is the same as the angle this chord is going to subtend at the circumference, which is this particular angle here. Okay, and this is at the center. You see, they are from the same chord, and they have an angle subtending at the center as 108. We have the same chord subtending an angle at the circumference. So the one at the center is twice the one at the circumference, and the one at the circumference is the same as the angle between the chord here and then this particular tangent, because this chord subtends an angle at the circumference here. So what we can say is that therefore our angle SQR, okay, SQR is, since it's the same as here, it is half of the 108. Okay, half of the one, because this angle is the same as this angle. So angle SQR is half of the 108. Half of 108. 54 degrees. That is 54. So our answer is C. 54 degrees. So let's continue with our objective question. This is question 43. Okay, in the diagram, triangle MPN is inscribed in a circle. That means it's in the circle and touches, or the vertex touches the circumference of the circle. As you can see, MQ is a tangent to the circle at M. MQ is a tangent to the circle at M here. Find triangle MPN. MPN. So we are looking for this angle. All right. Okay. So this is tangent, and what we know is that an angle between, this is also what, a chord. This is a chord. This is a tangent. An angle between a chord and a tangent is the same as the angle the chord subtends at the circumference. So here is going to give me 73 degrees. So if here is 73, then here is 73. The angle between the tangent and the chord is the same as the angle this particular chord subtend at the circumference of the circle, that is here. So after that, the interior angles of a triangle, the sum 1, 2, 3 will give me what, 180. Then I find. So simple. So what we can say that angle MNP is going to give me, is also the same as, it's equal to 73 degrees. So here is 73 degrees, angle MNP. And then we are finding out angle MPN. Angle MPN is 180 minus the addition of these two, 58 plus 73. Okay, since the sum 1, 2, 3 will give me 180, then when I add these two and subtract from 180, I'll get my answer. All right, 58 plus 73, and that will give me 131. And 180 minus 131 will give me 49 degrees. So my answer is A, 49 degrees. Angle MPN here is going to be 49. So now when you add all the three, you are going to get what? 180 degrees. So that is my answer, 49 degrees. All right, so this is our last question on the objectives on circuit theorem. So in the diagram, PR is a diameter, PR. Okay, so here is the center, so PR is a diameter. So if PR is a diameter, then what will happen is after an angle of 90 at the circumference. So we should take note of that with center O. Okay, find the value of angle PQS. PQS, so this particular angle PQS. So how do we find the angle PQS? Okay, so we know that this particular angle here is what? Will be 90 degrees. Okay, so if that is the case and that particular angle is going to give us 90 degrees, okay, then this side is the same as this side. So what is going to happen to the base angle? Okay, if this side is the same as this side, then the angle here is going to be the same as the angle here. All right, so these particular two angles are going to be equal. And if here is 90, what will happen? Here will be 45, 45. So that 45 plus 45 will give me 90. Plus the 90 will give me 180, because this is PRS, it's a triangle, 1, 2, 3. The sum will give me 180. And look here, this is a chord. All right, this is a chord. So the angle that this particular chord or this arc subtends at the circumference of the circle in the same segment are the same. So if this is my arc or this is my chord, then from this chord I get the angle at the circumference at here, from P to here, and SR I get my angle at the circumference here. From this same chord I get the angle at the circumference from S, the line here, and from P here also meet here. So this angle and this angle become the same. All right, become the same. So the angle here is the same as the angle here. Is that okay? So what we will say that angle PSR is going to be 90 degrees PSR, because PR is a diameter. So here will be 90. So and we know that PS is the same as what? SR. If that happens, then triangle SPSR becomes what? Becomes isosceles. And this line is the same as this line. It means this angle, the base line here, these two angles become what? The same thing. Alright. So let's say that since they are the same, if here is X, here is also X. So we know the angle SPR become the same as SRP. Angle SRP, which is, let's say, X. So let the two angles which are the same be equal to X. Then it means that X plus the 90 here is going to give you 180, and 2X is going to be 180 minus 90, and my 2S is going to give me 90, and what will be my X? 90 over 2 is going to give me 45 degrees. Therefore, the angle here is 45 and the angle here is 45. And I'm looking for angle PQS. And angle PQS is the same as angle SRP. So this angle is the same because they are from the same chord or the same arc, okay? And they are in the same segment, subtending at the circumference. So angle PQS is the same as angle SRP. So therefore our angle PQS, what is the value of SRP? SRP is 45. So therefore my angle PQS is also 45 degrees. So the answer is D, 45 degrees. 45 degrees. I hope you have understood. And circuit theorem is not difficult, so simple. Okay. Enjoy. I hope you have enjoyed our class. Make sure to share and then subscribe. See you again. Bye bye.